there's a lot of general talk, as we discussed throughout this podcast, about um, what are the facts behind climate change. And would you mind outlining what are the facts?
Yeah. And so I will give you, again, these are subjects with nuance and subtlety. So
Mhm.
I'll do my best to give you some
People,
sound
people,
bites.
people can buy
Okay.
this book.
But
Yeah.
yeah, and I've tried my best to tell the full story about many of these points in the book. Humans are influencing the climate through growing greenhouse gas concentrations, but also through aerosols that we put up by burning dirty coal or doing other things that produce particles in the atmosphere. The greenhouse gases exerting a warming influence, and the aerosols exert a cooling influence, not enough to balance it out by any means, but enough that you got to worry about it when you start to get quantitative. We have seen the average temperature of the planet, which is a difficult thing to measure, as you would imagine, go up by about 2 degrees Fahrenheit, 1 degree centigrade, since 1900. But interestingly, that rise has not been steady, even as the greenhouse gases have been accumulating in the atmosphere. We saw a pretty rapid rise from 1910 to 1940, and then it went down. The planet actually cooled some from 1940 to 1970 or 75, and then started warming again. And the rate of warming in recent decades is about the same as the rate of warming from 1910 to 1930. And that's really 1940. That's really interesting because it says there's got to be something else affecting the temperature beyond just accumulating greenhouse gases. In fact, human influences on the planet as a whole were less than 1/5 of what they are today before 1950. So the lesson is the climate varies a lot on its own, and untangling the variation due to human influences versus what's natural is a major challenge in climate science. We do that by trying to understand what the climates were in the past. We had thermometers back to about 1880 over a lot of the planet. Beyond, further back than that, we have various fossil records, historical records. And then we have today, of course, satellites and floats going through the ocean. So very important, because the ocean is really where climate happens, because it stores all the heat. The atmosphere changes every few days, but the ocean takes decades to change. So we got to understand the ocean. And when you do that, what you learn is that at least in the last 100 years, apart from the warming of the planet, most extreme events show no detectable trend. Droughts, floods, hurricanes, and no detection of human influences on hurricanes over almost 100 years. Most people are kind of surprised by that. You can look at other extremes, small scale storms, thunder, storms, hail, no effect. Sea level in the last few decades has been rising a little more rapidly than average. Do you know, so I can ask you a question, I'll give you a quiz. Do you know how fast sea level is going up at the Battery in Manhattan, the tip of Manhattan? Okay. About 1 foot every century. That's not a lot, is it? It's like an inch in a decade.
Right.
Okay? The last couple decades have been a little higher than that. But if you go back 40 or 50 years, it was a lot lower than that. And go back again, it was a lot higher than that. It's in the book, you can see the graphs. This is not Steve's data, of course, this is official data from NOAA. And so there's a lot of natural variability in the system. And it happens on long time scales, many decades, and untangling that from human influences is a pretty difficult job.
And sorry, I don't mean to interject.
Please, no.
What causes that variability? I assume there are multiple factors.
Some of it is, a little bit of it is natural forcings, as it's called, changes in the sun, volcanoes go off and they cool the planet a little bit. But a lot of it is poorly understood internal oscillations of the climate system, internal cycles in the climate system. They're quite definite. It took a while to discover them. There's one in the Atlantic called the Atlantic multi-decadal oscillation. There's one in the Pacific called the Pacific decadal oscillation. These take about 60 or 70 years each. Most people are familiar with El Nino, which happens every 5 or 7 years, takes about a year or two, much shorter time scale. The models do not a bad job of describing that, but they're pretty clueless about these longer term cycles. And unless you get them right, you don't know whether what you're seeing is a result of the cycles or it's a result of human influences.